In this demo, we are going to look at one of the components of the Graph-Scrutinizer, namely the component responsible for approximate graph summarization. As a first step, we are going to use a tool from the Graph Inceptor, which is going to be used to convert an RDF graph, the BSBM 14M dataset, into a binary format which we are using in the graph summarization. After that, we are going to do the setup. Now what we see here is a couple of parameters which are important. So we have a depth of 4, meaning that we're going to look 4 hops deep into the graph for the bisimulation. Partitions 4 means that we are going to do 4 different partitionings or randomized partitionings of the graph. Rows 4 means that we are going to use 4 different hash functions for each of them before making any of the decisions. And the relation count of 40 means that we're going to have at least, at most, 40 different relation types in our graph. Then we are going to export this working directory variable so that other parts can also use it. And then we are going to run our hasher. So this hasher is first going to read the graph, obviously. We can also see a couple of statistics here. So we see about 3 million nodes, about 30 million edges, and 40 edge types. And now the hashing has already run, so it has basically performed about 3.2 million or 3.3 million hashings and created 4 partitions each with a different size of 47, 41, 48, and 64, so they can be varying size. The size can be different every time. But you also see we have a throughput of about 1 million triples per second, and accuracy latency of 13 seconds, meaning here we are working in a batch setting, so we have to do all the triples before we can actually see the actual output. Let's now look at a different setting. So this is a setting in which we do stream processing. So what we're going to do is we're going to take RDF, we're going to convert that into the binary format. This is going to be directly piped to the hashing request injector. And this request injector is going to take the graph and then also interleave it with actual requests to perform hash operations. The LSH graph stream hasher is going to take that binary format. Whenever it gets graph information, it's going to add it to the graph, and whenever it gets hash requests, it's going to perform hash requests immediately. Now for this we need 3 different terminals. And so what we are going to do first is we are going to make a pipe. So what we're going to do here, so we're going to make a pipe called stream graph, and we are going to take the Graph Inceptor tool to pipe the information to this streamed graph pipe. What we're going to do next is we're going to take we're going to make another pipe over here. So we're going to make a pipe called output pipe.bin, and then the stream hash injector is actually going to read from the stream graph pipe, inject the hash request, and write to this output pipe over here. That is what's happening now. Now, maybe we should note that actually nothing is really happening yet until we have done the final step, and that we are going to do now. We are going to take the LSH stream hasher and going to start running it. And so only now the output is being pushed into these pipes, and you can also see a very low latency here. So they're basically here now 700 and now 800 requests, and immediately after these hashing requests have been dealt with. So there is an extremely low latency, but you will see that the throughput is much lower than in the previous case. So now we're only at 4 million triples, while before this would already have finished all the triples in the dataset. So this was a short demo. I'm going to stop this over here, and we'll continue with the presentation.